Let's compute the sample standard deviation, and we're going to do it 3 ways. And for the video, we're going to do sample data set A, just made these numbers up, 2, 4, 6, 8, 10. And I computed the mean, which is the sum of the data values. That capital sigma in the Greek alphabet is for sum. It means sum them all up. That's all there is to it. So you sum them, divide by how many, and that's how you get an average, which is the same as the mean. So you get 6. And here's another data set, set B, and 4, 5, 6, 7, 8. X bar, which is the mean, stands for the mean, is the sum of them, just like this one was, and divided by how many there are, 5, and that's 30 over 5, which is 6. So both data sets have the same mean, and I'm doing that for simplicity. They don't have to have the same mean, but I picked 2 to do, so we're comparing apples to apples. But we see that the data in set A is more spread about its mean than the data in set B is about its mean. So what I mean here is, when you look at this, here's the mean, and these data here are farther away from the mean than this data is. Here's the mean in this one. It's 5 down to 4. So this data set here, set B, is tighter to the mean than data set A is. A is more spread out. Okay? And down here we see that the whole idea of standard deviation is that the standard deviation of the data set is the measure of the spread of the data about its mean. That's what it is. It's a measure of the spread. The more spread out it is, like data set A is versus B compared to B, the more spread, the higher the standard deviation. So we're going to calculate the standard deviations for both sets above, and we're going to find out that set A will have a higher standard deviation than set B. Alright, so here's the computation of the standard deviation for the data set A. Method 1. 1 is from the definition. And the definition of standard deviation for a sample is this right here that you've seen in your materials. Alright, so it is basically a measure of the spread of the data. So how's it doing that in this formula? See, each x value is subtracted with the mean, so you're getting sort of a distance from the data value to the sample mean. So that makes sense with the definition that it's the spread. Then you'll get positive and negative numbers doing this though, and if you added them all up to try to get some kind of average, they'd all cancel out to 0. So we square them, and then we sort of do an average, but it's dividing by n minus 1 instead of n for technical reasons. But it's n minus 1 for this. So we're going to sum those squared differences. Sum the squared differences, divide by n minus 1, and then take the square root of the whole thing. So to accomplish this formula, you look at the various parts of it, and you make a chart to accommodate the parts. So you got your x, you got your difference between x and x bar, and you have your squares over here, and then you're going to add up those squares and get a number, and then you're going to put it in the formula. So here's your x data, subtract the x minus the mean for each data value. And here's your differences. Okay. Then the formula says to square those differences. Square them like this. And so you get these numbers here. Then the formula says to add those up. Add up those squared differences. And these add up to 40. Then stick it in the formula. S is this here, so we're just going to write it over to here. Standard deviation, little s, is this formula here. Put in the sum of the squared differences, that's the 40. That's this part right here, that was 40. N is, there's 5 data values. So n minus 1, 5 minus 1 is 4. So it's the square root of 4 over 40, which is the square root of 10, which rounds off to 3.16. And as to which decimal place to round off to, you usually do that in the context of the problem. So 3.16. Okay, so now we're going to move on to method 2, which is the so-called shortcut method. It's shortcut only because it has data lists, and it's easier for a machine to do it this way, a little faster. Okay, so here's your definition, formula of standard deviation, and then a bunch of algebra happens, which is an interesting algebra problem to do. It comes out equal to this, exactly equal. Okay, so you're just going to have to believe that unless you want to sit down and try to do the algebra. Okay, so then we're going to accomplish that formula. So to accomplish that formula, looks like we just need a sum of the individual data values squared. That's important, that the difference between this one and this one over here. This is the sum of all the x's and that quantity squared, completely different. But that seems like that's the two we need. So we're going to make a chart that does those two. Here's your x values right here. The sum of the x, we needed a sum of the x, which was over here. We needed the sum of x here. So the sum of the x is 30. We also need a sum of the x quantity squared. So that's over here, 900. 30 squared is 900. Then we also needed a sum of the x squares. So you square the x's right here, make this, get these values here, sum them up, and you get 220. So you can directly see that the sum of x quantity squared, which is 900, is not at all the same thing as the sum of the x squares. Then you accomplish the formula. The formula says n times this minus this over n times n minus 1 square root. So we're just going to plug everything in. The sum of our x squares is over here at 220. The n is, of course, 5. The sum of x quantity squared is 900. That's over there. And, of course, your n minus 1 is 5 minus 1. You simplify it down. You do the division. You get the square root of 10 again. That's exactly what was gotten before. Exactly equal. Square root of 10. Square root of 10, which is, again, approximately 3.16. Now, the third method, calculator method, and I'm doing it on a TI-84, but it works on an A3 also. Okay, so we're going to do it with the calculator. Go to the Stat button on the calculator. Then you see this menu here. Okay, hit Edit, which is the first one, enter that, and you see this screen here. I'll show you later how to, in this video, how to erase off data if there's data already there. So then you put the data into L1. Okay, 2, 4, 6, 8, 10. Put it in there. Then go to the Stat button again. Arrow over to Calculate, and you see here's the Stat button. Arrow over to Calculate, and you get this menu here. Choose one variable stats, which is number 1 here, one variable stats, and you get this screen here. arrow on down to calculate and press enter, and you get these this window right here, and you see the standard deviation of the x, the Sx, is right here, not the sigma x, the Sx for the sample data set, 3.16. That's what we got earlier, 3.16, and the rest of the decimals there is the square root of 10. So that all checks out. Now, what about data set B? We're going to compare that to A to see if it really did have a tighter or smaller standard deviation. So I'm just going to do it the calculator way because that's the absolute fastest way. 4, 5, 6, 7, 8. So here I had my data in here from before. I want to erase that out. So what I do is I arrow up to L1, then I hit clear and enter, and it clears all that data out. Then I'm going to enter in the new data, 4, 5, 6, 7, 8. I'm going to do my same calculator steps that I just did above, get to the one variable stats, and we see that the standard deviation of this set B, is 1.58, which is indeed smaller than the 3.16 like it was supposed to, and that is because data set B, its data is tighter to the mean, so its data is less spread, so it has a smaller standard deviation. One thing else I wanted to mention was some notation here. S is for the standard, the sample standard deviation. X bar is for the sample mean. Sigma, Greek letter small sigma, is for the population standard deviation, and Greek letter mu is for the population mean.